class, in today's lesson we're going to be covering 2.3, which is a lot about different postulates, which you can see this massive table below here, and diagrams. And honestly, if I'm going to be honest with you here, it's more about the diagram piece. And so if you see here in the essential question, it says in a diagram, what can be assumed and what needs to be labeled. Now, I don't know if I would say assumed, or I mean labeled, but I would definitely say this assumed piece. So what they're going to do is they're going to give you a diagram and they're going to ask you like if you can assume this is true based on the information you have, okay? So I would probably say that's the key piece. Now, we've talked about postulates before. Remember, postulate is a word that Euclid used, and a postulate is something that we assume true, really without a lot of proof. And what I mean by that is postulates are kind of things that are just like, duh, like you should know that, like it makes sense. We don't really need to clarify. And so if you notice, there are 7 of them listed below here, okay? Now, you don't need to memorize these. I have told you there are certain things you do need to memorize. These are not one of them. But I do think it's good for you just to have an understanding of them. So I'm not going to go through all 7 of them right now, but I just let's start with the very first one because it's listed first. It says 2-point postulate. Through any 2 points, there's exactly 1 line. Which makes sense because think about if I were just to put 2 points here and here. If a line has to be straight, how many ways could you connect those 2 dots? You'd all be saying there's only 1 way. So it's something that makes sense, but think about how many times you have been in algebra class and your teacher would give you like say slope-intercept form. And so you would go up to 1 and then you would do your slope, rise 2 over 1. You really only have to do 2 points because that is really all you need is 2. But a lot of times in algebra class, we used to always tell you to do a couple more so that you had a better idea or shape of the line. But this postulate is telling you that you really only need 2, okay? And then notice the second one is in a way kind of the converse. So the converse is now saying that if you have 2 points, there's a line. So it's a postulate. So we don't do a ton with these, but every now and then they'll kind of like pop up or they'll like refer to different concepts here. So if I was you, and I'm going to go through one more, I'm just going to kind of go in order here, number 3. I'm going to do one more, and then if I was you, maybe pause the video and kind of read through them, but I don't think you have to again, spend a lot of time on it. So in the third postulate here, so it's called the line intersection postulate, and please don't worry about these numbers. These numbers are only specific to your textbook. Euclid had nothing to do with these. Or if you were to switch textbooks, maybe in another 2 years we switch textbooks, or if you move out of Hudsonville and you go to Jenison, I don't know what textbook series they use. So these numbers kind of are irrelevant, so just don't worry about those. It says, if 2 lines intersect, so just stop right there. If you draw yourself a line, now you draw yourself another line. I don't care what angle you put it at, but draw yourself another line. If these lines intersect and they're straight, isn't there only 1 point that they could cross at? Because they're straight. If they could bend, if I had my original line, and then if a line could bend, well, then I could have it cross at more locations. But if lines are straight, then this makes sense. So again, these are things that we kind of already know, but you have to remember in the year 300 BC, they didn't really know a lot of this stuff. So this is like almost, again, it's like a dictionary. It's really like the Bible of math. It's everything that we hold to be true in mathematics. Euclid wrote down in what's called the Book of the Elements. Okay, so if you turn to the next page, I did not give you a lot of these. If you actually look in the textbook, there's quite a few more. I just gave you a couple to kind of practice. And so if you look at number 1, they just want you, or 1 through 4, they want you to identify which of those postulates is being used. So again, I'll do the first one and then maybe you can pause it and try the other 3. So if this, how do we know this? Well, if you notice, the only thing that's really changing is I have 2 lines and then notice there's a dot in the middle. So basically what they're saying is if 2 lines intersect, then they cross or intersect at one point. So that must be this postulate. So the answer that you would write down would be the line intersection postulate. So they're just trying to get you to practice them, okay? So why don't you just pause the video here and try the other 3? All right, hopefully you quick tried them. If you look at number 2, again, there's not much difference between these. The only thing that's different, if you notice, it's this arrow that's right down the middle. So what you're kind of looking for is when planes intersect, which dead giveaway is right here because it's the only one that has a diagram of a plane. When planes intersect, they form a line, which if you kind of think about whatever room you're in right now, think about a vertical wall. So like maybe the wall directly to like your left or your right. And then think about like the ceiling. Where the ceiling and the wall come together is an entire line. Now, because you're in a room, it looks like it stops because you have another wall. But technically, lines go on forever. So that's why they're saying the intersection is a line. So they just want you to say plane intersection postulate, which again is from this one right here. Okay. All right, number 3, notice 3 dots and then a line connects them. Okay, so right here. Now notice it says through any 2. We only need 2, but they gave us 3. But as long as we have at least 2, which we do, then we're fine. So this was the first one, the 2-point postulate. Okay. And then the fourth one, notice we have points, and then notice we have a line. Okay. So if you kind of look, notice there's 2 pictures here, but notice this 6th one also has the line. So it says basically if points lie in the line, then the line that contains them, or I like to say connects them, also lies in it. So it would be that, what is it? The 6th one. Sorry, I didn't know the number. So it would be the plane line postulate. Now, again, I can't stress enough. Please do not go and memorize these. Just maybe once in a while, read through it. Like if you get to class early, just kind of quick glance them over. More than anything, the more you read the wording and then look at the picture, just the more it's going to help your brain process information. So I am never going to ask you a question. These questions are not on the quiz or the test, but they're good thinking questions. Remember, part of math, part of school is just to get you to think, okay? So it's a good thinking question. Now, the piece that you do need to know, let me grab a different highlighter here, is this section. I don't remember exactly how many. I don't know. There's a couple. There's a few of these on the quiz test. Okay. So I can't remember if I think the quiz is after this lesson. So again, I get it all kind of confused, but these are on the quiz test, both one or the other. I know they're on there. So what you want to do, and the directions are the same. It's just they go with different pictures. So the directions are the same. What you want to determine is there enough information to say that it's conclusive, which is really the same thing as saying it's like a true statement, but for whatever reason, your book loves the word conclusive. So just try to get in the habit, because I don't want you to be thinking true or false, and then that's not one of the options when you go to big ideas. and then inconclusive. So inconclusive is sort of, again, like we don't have enough information. So it's kind of like false. So what you do is you just look at this and you say E, B, D are collinear. So you look and you say E, B, D. Are they collinear? And it definitely looks like I could connect them, but I don't know for sure, because what if it's off slightly? So if there's not a physical line, I would say inconclusive, because I don't know for sure. Even if I try to put a ruler down, which I don't have a ruler here with me, but even if I were to try to put a ruler, how do I know for sure that they fall in a straight line? Maybe one of them is a tiny bit off. So if you can't say without a doubt, then you just put inconclusive. So I'll do another one with you here. Number 6, it says AB, which is right here, is perpendicular to plane S. Do you see the little box? As long as I have that marked, I would say, yes, this is conclusive, like because I know what this little box means. And so that's what they want you to do for these questions. So if you want to pause the video here and try these, I definitely think it would be worth you trying on your own. But after this number 14, that is the end of the lesson. It's a fairly short lesson here, so just go ahead and give them a try. Okay, hopefully you paused it. We've got line CD and line BC. Now notice right here, I can't tell for sure if that's 90. It could be, but I don't know for sure. So I'm going to say inconclusive. B is the midpoint of AF. Again, the way this is drawn, it kind of looks like it might be. But again, how do I really truly know that this distance is the same unless you give me some more information or you have some additional marks? So I'm going to say inconclusive. You almost want to say inconclusive unless there's a, for sure mark on your picture. So 9 through 14 is the same questions, just different diagram. Okay. So we say EG, is it parallel to BD? And again, I don't know that for sure. This is 90, but is this one? So I'm going to say inconclusive. DGI, are they collinear? Kind of the same thing as up there. They surely look like it, but I don't know for sure, because what if I is slightly above or slightly below? I may not know. What if G is slightly above? You don't know for sure. AF, so here's AF. And this is kind of also helping you practice from chapter 1 how to read the symbols here, because A skips here and goes to F, so AF. Okay, AF and BD are coplanar. So if you look at the way this is drawn, there's a parallelogram around it. So I would say, yes, this is conclusive. It is within the same plane. All right, AC and FH, are those the same line? And I would say yes, because line AC goes on forever. Yes, it is the same line. All right, EG and AH. So this line and this line, notice the symbol. So yes, I would say they're perpendicular. So I'd say that's conclusive. All right, EG and BD do not intersect. I don't know that for sure. Who's to say that this line right here isn't tilted on a tiny angle? And if we were just to kind of go on forever, so if we were to take this line and go, 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 who's to say that it wouldn't eventually hit at some point? Now, I mean, maybe it won't, but how do we know for sure? So I would say this is inconclusive. So lesson 2.3 is pretty short. This is the key piece that you need to know, the whole inconclusive versus conclusive. The postulates are just good vocabulary, okay? And that concludes the third lesson.